Professor Bumbleweed here. Electricity starts as look. Amber picks up fluff, then escalates into lightning, batteries, and spinning generators. In a few minutes, this explains how humans stumble from tiny static sparks to the power-running modern life. Try not to blink. This mini-tour stays fun and actually useful. Sparks that attract, jars that store charge, storms that prove the point, and batteries that keep current flowing. Then magnets join the party, and generators do the heavy lifting. Enough tease. Take a closer look. Here comes the original discovery. Rub amber, get clingy particles. Static charge forms by friction, and lightweight stuff feels the force first. No magic, no tiny invisible gremlins, just charge separation and attraction. It looks cute now. It scales up brutally later. Static charge behaves like a drama queen. It attracts, it repels, it spreads by contact, and it leaks away over time. Watching a pith ball or electroscope move makes the invisible visible. These simple tests turn weird amber trick into a measurable physical effect. Curiosity turns into science when someone tests it on purpose. William Gilbert studies rubbed materials and describes electric effects from amber-like substances. The big win is method. Compare materials, repeat trials, and use simple indicators to spot charge instead of guessing from vibes. The Leyden jar matters because it stores charge. Two conductors separated by glass hold energy in an electric field, then release it during discharge. That idea, storage and release, opens the door to real experiments and safer comparisons. Also, it looks terrifying. Fair. A lab spark and a lightning bolt follow the same basic idea. Charge separates, then discharges through a path. Reports about Benjamin Franklin's kite experiment push the claim that lightning is electrical. Either way, the lightning rod soon proves the point by guiding discharges safely. A lightning rod is not decoration. It provides a preferred path for electrical discharge, a conductive route down to ground. Instead of ripping through wood and stone, charge flows through the rod and conductor. This is electricity becoming engineering. Control the path, control the damage. This is the awkward phase of discovery. Biology meets electricity. Galvani sees muscle movement linked to metal contact and electrical effects. Whether the source is tissue or metal chemistry, the experiment screams that electricity can drive motion in living tissue. Subtle, powerful, slightly creepy. Alessandro Volta responds with the voltaic pile. Stacked copper and zinc separated by brine-soaked material. Instead of one snap of charge, it supplies a steady electric current through a circuit. This is the battery era beginning. Less spark, more flow. Finally, electricity behaves like something usable. Here is the plot twist. Electricity and magnetism are linked. Current in a wire nudges a compass needle, and reversing the connections flips the direction. Wrap the wire into a coil, and the effect grows into an electromagnet. This is the backbone of motors, relays, and modern machines. Michael Faraday shows the real magic trick. Motion makes electricity. Move a magnet near a coil, and current appears. Stop the motion, and the effect fades. That is electromagnetic induction, the principle behind generators. Spinning coils and magnets scale this into power for cities. Simple idea, huge impact. So the discovery of electricity looks less like a single moment and more like a long chain. Static charge from rubbing, charge stored in a Leyden jar. Lightning connected to lab sparks, steady current from a battery, and induction driving generators, like the static picture on the television spells out. If this helped and kept you entertained, tap like so the next topic does not come from a coin flip. Drop topic ideas in the comments too. Otherwise, I just stand here in silence, dramatically gesturing at a television like a very colorful statue. See you around.